Hello everyone, thank you for visiting us here at Intergeo. We are Drone Harmony, and I'm David. I'm a VP Product at Drone Harmony, and I'd like to really quickly show you our platform, explain to you what it does, and answer any questions that you might have after the presentation. So it should take about 30 minutes, and let's dive into it. So the Drone Harmony platform consists of three main pieces. So we have a web platform, a mobile application that runs on Android devices, and a cloud that kind of connects the two first pieces together. The goal of the platform is to perform data acquisition using off-the-shelf drones, and Drone Harmony specializes in vertical infrastructure and complex mapping and inspection tasks. So with our platform, you have the ability to easily inspect and map complex use cases, complex scenarios, buildings, cell towers, or complex terrain in various ways. And what I'd like to show you today real quick is how you can use mostly Drone Harmony web application in order to achieve this goal, and I'll also touch upon some aspects of the Android mobile application and the cloud. So let's just switch over to the Drone Harmony web app and start looking into it. So here I am logged into my account at the Drone Harmony web application, and you see that the basic view is this kind of map view where we have a map, and we can pick what type of map we're looking at, but at the moment we're looking at the Google Maps layer here. And what I'd like to do is I'd like to start planning some flight missions for me somewhere within Zurich. And this is the first kind of demonstration that I'll show you. Before I demo any of the initial kind of steps that we're taking, let's take a look kind of at the finished state once we've done our work. So I remind you, the web application is our main planning tool in Drone Harmony. It enables us to plan missions and to synchronize them to the cloud for our operators afterwards to execute in the field. The operators will download the data from the cloud on their mobile apps. This happens through a synchronization step that is happening automatically. And you can imagine the web app is our kind of mission control in the office. So if we're digitizing one, two, or even many infrastructure assets, we might be sitting in the office and we're planning the basic missions or the main missions here, where the operator will afterwards be receiving these missions on their mobile device, Drone Harmony application, to execute the missions, to make adjustments if needed, and then execute them. So let's dive into a use case. So for this, I'll just load an existing state. So I can go here on the top left, I'll get to my menu, and I can open site storage. Under site storage, I have the option to load a site. You can think about sites as inspection sites in which we've planned some missions, perhaps already executed some missions. So I'll just pick here the first one called Industrial Site, Zurich, and I'll load the latest version thereof. So when the site is loaded, I start seeing some overlays over my map view. So you see that we've zoomed into some area. This is in Zurich, and we have a bunch of overlays here on the map. The overlays represent one of two main things. They can represent information about the environment, things like no-fly zones, buildings, towers, points of interest, or they can represent missions that we've already planned. So the polygons, the colorful polygons, and this POI symbol here, they represent the geometry of the environment, whereas all of these dotted lines, they represent missions that I've already planned for this environment. So let's quickly click on one of these missions and see what level of detail can we go down to for a single mission. So you see that once I clicked on the mission, we have a very detailed view of how the single waypoints of this particular mission look like. I have information about their height, and I can interact with these waypoints on a one-by-one basis or on a group-by-group basis. So I have very low level interaction capability here on the level of missions. So you can think about the web app as this kind of interface that enables you to interact from a very high level with sites all the way to the very low level waypoints, single missions, single structures or assets within the environment. So let's undo this change that I just made. And let's switch over to another interface within Drone Harmony, and this is the key interface that enables us to see what actually is behind the scenes, behind these overlays. And this is the 3D interface. So on the top right here, I have view type, and under view type I have three options. 2D map, this is the view we're in right now. 3D scene, which we'll switch over to right now, and 3D terrain, which I'll touch upon later. So let's switch over to 3D scene. So when I move over to 3D scene, you see that I actually have a 3D view of my site. I realize that my objects, my site geometric primitives are three-dimensional. They have a height. And my missions, some of them are extremely vertical, like this facade mission over here. So using this 3D view, I can actually visualize very, very well what is actually happening. I can see the site in a very, very clear way. I can navigate around it and zoom in to different parts of it. I can see the missions, how they relate to the site. And not only the visualization is important, the key thing actually in Drone Harmony is that the ability of us to design such 3D scenes enables us actually to automate the generation of these missions. So let me quickly show you how I can actually generate a mission for this site very easily based on this 3D model. So what I'll do is I'll turn off the visibility of the other missions for me to only see the mission that I'm planning now from scratch. So I'll come over here to the filters side, to the filters tab, and I'll go over to plans, and I'll turn off the visibility of all the plans. And this way I can only see my site. The plans are still here, their visibility is just turned off. So this is my site, and I can take another look and realize what I actually want to do. So let's plan another mission. Let's plan a similar mission to what we've seen before, because that's kind of an interesting use case. Let's plan a facade mission for this L-shaped building over here. So to plan the mission, this is very simple. We move over here to the plus sign down here, and this enters into the so-called plan catalog. The plan catalog is a collection of plans or patterns that you can apply to your scene. And here we start seeing kind of the workflow in Drone Harmony and what makes it kind of unique. In Drone Harmony, we start with just designing a scene, and I'll touch upon how we can input the scene information into Drone Harmony later, but let's assume that we already have this kind of scene, this kind of geometric representation of our asset in its environment. The second step is to apply a flight planning pattern from the plan catalog to some elements in that scene. So in this case, we would like to inspect the facade, so we'll go to the inspection tab down here, and let's pick perimeter verticals as the pattern that we would like to apply. Once I've picked the pattern, I'm asked to what element in my scene I want to apply it. And here I have a list of all the elements that are relevant for this particular flight plan. So all of these things represent what could be buildings, in the environment. And I'll pick this L-shaped building here. Once I pick the asset to which I want to apply my pattern, I'm guided through a simple linear workflow. First off, I'm told to select a Liftoff location for my mission. So let me zoom in here and try to pick a nice location here on the street. So we won't spend too much time optimizing this, but let's say this place over here. And I can pick a land-off location, or I can just pick the same. Then, when I pick the takeoff and landing location, I am again entering this kind of dual view. On the right, I have my usual Drone Harmony view. It can be 3D view, it can be 2D view, whatever view I feel is most informative for me. to plan this kind of mission. And on the left, I have a set of parameters that I can set. And these parameters are specific to the mission that we are planning right now. So for example, start altitude is the minimum altitude at which we want our mission waypoints to start. Side offset represents the offset from the side of the building that we would like to achieve for this particular facade inspection mission, and so on and so forth. So let's real quick plan a mission that, let's say, has the same side offset, or let's adjust the side offset a little bit. Let's make it a bit bigger. And after doing that, you see that I immediately have a reaction. So I immediately have a recomputed new mission with the new side offset. Now let's say that what we want is we want to inspect the inner part of this building all the way up to the outside here and see what happens. So for this I can go to the coverage tab, and the coverage tab just tells me what part of the circumference of the building do I want to plan the mission for. And here I have two sliders. One slider is just sliding around the current mission that I have. So if I slide it a bit around, you see that the whole mission slid a bit in clockwise direction, or around the thing here. So let me pull this all the way back, because actually it was in a good position before for where I wanted to start my mission. What I need to adjust is I need to extend the flight a bit more. So here I can pick a different number. I can input it either manually, for example 35%. Let's see if we already reached all the way out. So almost. So let's just pick 40, or I could use the slider to slide it through. So now, after I've adjusted these parameters, I have a mission that achieves what I wanted, and I can save it. If I save the mission just joins the state. I can, of course, give it a new name. I can call it facade new. And when I save the mission will remain in my state. And if I save now the state back to the cloud, I will again have this information stored in the cloud, and my operator in the field will be able to synchronize and execute this flight mission. Now, the 3D view is not just a viewer. There also is a lot of interaction that you can do. So let us zoom in into this mission that we've just generated. And let's say that we're not happy with the angle of some of these waypoints. Well, that's not a problem. We can pick these waypoints, let's say these two waypoints, just for the demonstration. And we can adjust any relevant attribute of them. So we can rotate them, for example. We can rotate them a bit left or right, whatever we feel that we need to do. So there is a lot of high-level planning capability, what we've seen before, meaning the ability to generate automatically flight missions based on a scene, as well as a lot of low-level control for micro adjustments of the mission post-planning, so to say. Another important aspect is, why are we bothering to enter information about the objects around the building that we're inspecting? Well, there are two main reasons. One reason is this gives us some situational understanding of how the mission interacts with the rest of the environment. But more importantly, it actually gives our algorithms, or our mission planning software, the ability to plan the missions around these obstacles. So as an example, you see this long blue building here that was in the way of our mission. If we had not modeled this blue object, our waypoints would go all the way down in these two vertical lines as well, which would mean that we would have a non-obstacle avoiding mission. So the ability to enter these kind of additional structures into the scene enables the planning algorithms to plan around them. And this is a layer of obstacle avoidance that's very important, because we're able to plan good missions around knowing the obstacles at hand. Of course, there will also be the layer of obstacle avoidance built into the drone, should you be using a drone that has this capability, that will be enabled while we're executing the flight. So dynamic obstacle avoidance together with planning obstacle avoidance gives us the best result, as well as the safest way of achieving this goal. Okay, So this is a short demonstration of how planning works. Now, in the mobile application, we have a very similar interface. We have the ability to import or to outline 3D structures. We have as well the possibility to plan missions in pretty much the same way as I demonstrated here. So the mobile app has a lot of the same capabilities, and this is very important because oftentimes when we're in the field, we need to make adjustments because we are not aware of all the obstructions, of all the constraints that are available out in the field while we're planning missions in the office. So these capabilities are built into the mobile application as well, and the operator in the field will be able to react and to adjust missions if necessary. Okay, so let's switch back to the map view and take a quick look at how different sites look like on the map. So first off, what we've seen now is how a single site looks like and how to create missions for the site. Now let me deselect this mission that I've selected over there, and let's touch upon the question of how to import information into the environment. Now, Drone Harmony has a basic 3D modeling, let's say you can call it language, or a basic form of 3D objects that can be used, and those are these polygons which can gain a height, they can intersect with one another as they do here, and you can use these kind of shapes to model quite flexibly a lot of different types of structures. How can you input such information into Drone Harmony? Well, there are three main ways. Way number one is just to outline them. So I can pick this polygon tool over here, I can zoom in, and I can start outlining this building here, using my map view as visual reference to where I should be outlining the building. Once I'm done outlining, I can choose to give this guy a height, so I can set a height for it, let's say 25 meters, and I can save this. And now this is a scene object, just as every other scene object. It will be taken into consideration in mission planning, obstacle avoidance, and so on and so forth. Let's take a quick look in 3D. Here this is. I can actually adjust it from here as well in case I want to. I can set a different color for it, or I can decide to change its height. So there are many editing options in 3D view, whatever makes sense for 3D environment. Now the second way I can import this kind of information, so polygon type information, into the environment is I can use a new tool that we have, which is the OpenStreetMap import tool. OpenStreetMap enables software vendors like ours access to geographic information about structures. And let me quickly show you on a different area here in Zurich. Let's just zoom into somewhere over here where we have structures, and I will show you how this tool works on kind of a new environment. So let's say this area here, and let's say we would like to outline the buildings around here. I can of course start by outlining using the polygon tool, but let's try to use this building import tool. So by pressing on the building import tool, we're informed what we're using. We're using OpenStreetMaps as a contributor for the data behind the scenes. Let's press on continue. And the next thing we have is we have this polygon that enables us to choose what area do we want to import information in. So there is a limit to the size of the area, just because there can be a lot of data behind the scenes for such an area. But let's pick this kind of area and press continue and see what happens. So if there is information in OpenStreetMaps around behind this area in the map, we will be able to see this information actually immediately pop up in Drone Harmony right now. And you see this here. You see that we were able to outline the buildings that are in this area. And of course we should take care, and maybe there are some things missing in our environment, but this speeds up very significantly our scene building step, as well as giving us very accurate information about the footprints of these buildings. I can look at this now in 3D view, and you will see that in this case we have kind of flat areas. So we will need to give them height because this information was not available in OpenStreetMaps. But at least we have the footprints, and this is a great start to start building a scene. So I can pick a building here, I can set a height of 20 meters, and I have a three-dimensional structure now. Okay, that's an example. In some cases, we will be able to import information and we will immediately get the 3D data as well. So I think maybe in New York City, which is probably not the first idea of where you would like to be flying drones, but it's just as an example. The OpenStreetMaps tool will enable you to actually import the heights as well. If I'm not mistaken, we can give it a quick try. It doesn't really hurt us to try, and then we'll see how that will look like. So here I'm zoomed into just somewhere in Manhattan, and I can try to use the import tool here just to see the difference. So let's center it over here, press continue and see what happens. So the import has finished, and we have something behind the scenes, and you see that here the height information is populated. So if we switch over to the 3D scene, you see how complicated of a scene one can very quickly import into Drone Harmony by just using this import tool. And we can start planning missions now for this scene. So now we've generated several sites actually in the environment. So let's try to understand how we can have an overview of all these sites together. So the easiest way is to go out and to click on this center view here. And when we're clicking on the center view, what we see that we have a kind of zoom out to all of our sites, and we can zoom into and interact with any one of the sites that is currently available here in the scene. In particular, we can click on this site, we can save it to the cloud, we can show it on the map or in 3D, or just remove it from the state. Let's remove this one from the state. So I remove this site from the state, I can center again. Now I can center on the two sites I have in Zurich. So you see that this is pretty much also this interface works like an asset management system for our data capture workflows. I can enter this site now in 3D. This is the site that we've just started generating in Zurich, and I can switch to my other site easily as well within the 3D viewer. So I have the ability to navigate between sites in 3D or on the map. It's all very simple, and this capability is one of the main reasons why kind of the system operator that's managing the different sites and making decisions on how data should be captured in different areas. This is kind of a key feature that's important for them. Okay, last way of importing polygons into the scene that's worth mentioning is through KML import. I will not demonstrate this, but you can come here to the menu, import data, import areas, and you can load any KML or KMZ file, and the corresponding data will load. And this data can be polygons or lines. Lines are also important modeling structures that enable us to model things like roads, railways, riverbeds, and so on and so forth. Of course, many uses for lines as well. This can be part of the KML, or we can create the lines, outline them ourselves. Okay, so before I finish my presentation, I just wanted to show you how you can work also with terrain data in the application. So for this, let me load a terrain into the application. So terrains are digital elevation or digital surface models. You can use either one. So I'll now load the digital elevation model. For this, I'll go to Menu, Terrain Storage, and here I have a number of options. So I'll load terrain from the cloud because I have already saved some terrain and processed it in the cloud. So I'll go for Load Terrain. And let's pick the second one here, Sakurajima Tile 1, and load this terrain. So you see that a new site has appeared, this site over here. So let's zoom on to this site. This is somewhere in Japan. And this is how terrain file information looks like in map view. We are confronted with this kind of transparent polygon that will be in the shape of the terrain data and information behind the scenes. So in this case, we have this kind of square tile of terrain data, and we can visualize it and also plan missions for it. So let's quickly see how both of these things work. So let's move over here to the third view that we haven't entered yet so far, 3D terrain. And we can enter this view whenever we have terrain information in our scene. So I switch over to terrain view, and I can start seeing a 3D representation of my digital elevation model here. And as you can see, this is a very similar interface to 3D scene, except that what we visualize here is the 3D terrain information. Now, let's plan a quick mission for this. So for this, I first need to define some scene information here. This is just behind the scenes data. I need to define some scene information. So in particular, I can set up a polygon for a mapping mission here. So I just pick some polygon, and I can close this polygon, and we'll be able to start planning a mission for it. So this is an area now, and once I have an area and I have terrain, I need to make sure that my area remains inside the terrain. It will also work if it sticks out. However, if we're working on terrain-aware missions, it's important that we work in areas where terrain is available. So I make sure that I keep my polygon inside the terrain. And here, when I move to the plan catalog, you see that I have a second tab on the top, which is called terrain. And here under terrain, I have all my missions that are terrain aware. So I can pick, let's say, the first one here, terrain map. And I can pick this area here. And again, I'm guided through the normal process that we usually have in Drone Harmony for planning missions. Set liftoff location. So let's set this liftoff location, press to continue. And here we will have the same kind of interface. On the right, we see our terrain and the polygon overlaid over the terrain, together with the mission that's currently planned for me. You see that this mission is following nicely the terrain, and I can apply any change in the parameters here that I want. Let's make this mission much lower, 50 meters above the ground, and any change I make will compute and will be displayed here immediately once it's available. So you see that it immediately snapped down to a 50-meter grid. I can control many other important aspects like the overlap, camera parameters, and so on and so forth. Every change I make is immediately affecting what I see and what's computed behind the scene for me. So this is how easy it is to use terrain. Now, terrain can be used in 3 different ways. Again, I can save the mission, give it a name, new terrain mission, and I can save it and it's part of my state, just as any other mission so far became part of our state. So how can I add terrain to Drone Harmony? Real quick, and with this I'll conclude my presentation. So let's switch over to map view, just take a quick look how it looks like from the top, the same way as it does before. We have the white stuff for the missions, the blue are the polygons, and now we have these gray polygons that are also the terrain information. So to add terrain, we have the option to upload any terrain file in GeoTIFF format. So for this, we use this first option up here. In addition, we can import terrain through an API integration of Drone Harmony, which uses the Airbus World EM data. It has a resolution of 12 meters, so every 12 meters in both directions we have 1 point, and an accuracy of a few meters. So it's excellent for mapping missions at certain heights like 30, 40, 50 meters, perhaps not at 10 or 5 meters, but it's great for most mapping type missions. And whenever we either upload or import the terrain at Airbus, the terrain file becomes available in our cloud, and then we can download it here through the load terrain option. So you see that in the load terrain option, I have already many different terrains that I either uploaded or imported through Airbus. So all of these options are available. And the last option I just want to mention, and this is for the larger customers out there that need to work with terrain on very, very large scales. Let me quickly clear everything here and jump back to Zurich, Switzerland. This is, by the way, how we search for locations. We don't really need to navigate on the map. We can use the search option here. So for the larger customers out there that really need, for example, regional size terrain models or even country size terrain models, Drone Harmony is able to stream the terrain data directly from the Drone Harmony cloud to your front end. You don't need to load tiles if you'd like to be an enterprise customer of Drone Harmony. So to demonstrate this, let's just look at this area here in Zurich, where you can see I do not have any terrain information, seemingly, but behind the scenes I actually do have terrain information, so I can switch over to the 3D terrain view. So if I switch to the 3D terrain view, you'll start seeing the areas being populated once the tiles get downloaded from the cloud. And this option is an option that we make available for our larger customers that need to deal with very large volumes of terrain and would not like to need to always work with different terrain files in different areas. So I have some internet slowness probably with all these recordings now, but basically what you see is the terrain information being loaded here. This is terrain information at much higher resolution than the terrain information that I showed you before. This is a 2-meter grid. So in this area there's much more data, and we can plan terrain-aware flights anywhere we want in this area. And if I keep on browsing here left and right in kind of Google Earth style, the terrain tiles will continue populating as long as I stay in the realms of the huge terrain model that's behind the scene here, which is that of all of Switzerland actually. So we have customers that request populating the cloud, the Drone Harmony cloud, with their full terrain model, and this way they never need to worry about loading terrains, saving terrains, managing them in any way. They can directly access them through the Drone Harmony interface when they're logged in through their users. Okay, so with this I would like to conclude my demonstration. I remind you that I've only shown you here the Drone Harmony web application, but the Drone Harmony mobile application has a very similar feel and touch, except that it's also a flight execution app, apart from just a flight planning app. So with this I'd like to conclude. I thank you very much for your attention.